acceleration. This is our lesson 3 on this chapter of motion. Before acceleration, in the previous 2 videos we have done in lesson 1 and lesson 2 distance time graph. In these 2 chapters we understood the distance time graph for constant speed and for changing speed. If you have not gone through these 2 chapters, please go through them so that you understand lesson 3 nicely. So let us start by understanding the definition and the formula for acceleration. What is the definition for acceleration? The rate of change of velocity is called acceleration. So the whole statement that you see written in the definition, precisely the statement, if you want to write it mathematically, this whole statement looks something like this. So if in the exam, if you are asked to define acceleration, either you write it in words in English or you write it in maths. The formula. Both mean precisely the same thing. The rate of change of velocity goes in the numerator. It's rate. We are talking about the rate. So the time taken goes in the denominator. Change in velocity per unit time. Per unit time is called rate. So acceleration is change in velocity divided by the time taken for this change to take place. We'll understand the definition and the formula as we proceed through the video. Many students get confused when they apply the formula on acceleration. This video will clarify all your doubts and you'll learn to apply this formula and calculate the value of accelerations correctly. So let us start with understanding the unit for acceleration. As we know, as we have understood in the previous videos, that the unit is derived from the formula. What is the formula for acceleration? We just mentioned change in velocity over the time taken. So what do you have in the numerator? In the numerator you have velocity. What is velocity? Velocity is nothing but the speed in a particular direction. Velocity and speed have the same unit. What is the unit for speed? Meters per second. So the unit for velocity is also meters per second divided by the time taken. The unit here is, in the numerator the unit is meters per second. In the denominator the unit is seconds. So it's meters per seconds divided by seconds. Let us do some maths now. Numerator becomes something like this. Denominator stays as it is. So the whole unit changes to meters per second square, which is same as meters second minus 2. So what do you understand? What is the unit for acceleration? It is meters per second square. You can write either this way or meters second raised to the power minus 2. If you are unsure how to derive the unit of any particular quantity, you can refer my video. There is a video dedicated to understanding how to derive the unit of any particular quantity. Right? So let us understand the formula. Let us understand how you apply this formula through an example. Suppose that there is a car, a yellow car, which is moving from point A to point B. At point A, the speed is, say that it starts from rest, which is easy to understand. Starts from rest means what? Means it started from 0 speed. Let us take all the speeds in meters per second. Say that its speed at A was 0 meters per second. And it reached B. When it reached B, its speed was, say, 10 meters per second. And the time taken to reach from A to B, say it is 5 seconds. 5 seconds is the time. 5 seconds here is the time taken to reach from point A to point v, right? So how much is the change in the velocity? How much is the change in the velocity? 10, final velocity. Initially it was 0. So how much is the change? 10 minus 0. And how much was the time taken for this change to take place? 5. So what is your answer? 10 over 5, 2 meters per second square. So the acceleration was 2 meters per second square. So this here in this example we understood how to apply the formula for acceleration. We'll understand how to apply this formula in a more complicated scenario as well as we proceed through this video, right? Now the formula for acceleration, which is change in velocity over the time taken, can be written in terms of some letters as well. The formula for acceleration is v minus u over t. You all would have already seen this formula. The formula for the acceleration is v minus u over t. Now what is v, what is u, and what is t? U is the initial velocity. The u that you see here, it is the initial velocity, and v is the final velocity. What does it mean? Initial velocity, final velocity, what do these terms mean? What do these terms, initial and final, mean? Very, very important to understand if you want to apply this formula correctly. Initial, what does the term initial means? Initial comes from initially, right? Initially means something which happened previously. Final means the end point, the last point, or the last value of the time, right? Final value, what is the final result, right? Final comes later, initial comes before, right? So where was the car before and where was the car later? Car before was at point A, right? Initially it was at point A, and later finally the car was at point B, right? Therefore, earlier, before point of time, it was at A, so the speed at point A is initial velocity and it is denoted by u. And at later point of time, the car reached B, which was its final position. Therefore, the velocity at a later point of time is called v. It is very, very important to understand thing, because this is a thing where many students get confused, right? So let us take an example. Say that at point A, this yellow car, it was traveling, right? It started from rest. Say its initial velocity was 0 meters per second, and at later point of time at point B, its velocity was 10 meters per second, and it took, say, 5 seconds to reach from point A to point B. So what is the acceleration of this yellow car? What is the value of the acceleration? What is the value of the acceleration of the yellow car? Acceleration of the yellow car. So this will be v minus u over t. This is the formula for acceleration that we know of, and it is always a good idea to start solving the question by writing the formula first. So what is the final value of the velocity? 10. Initial value of the velocity, 0, and the time taken for this to happen, 5. So what was the acceleration? 2 meters per second squared. Now let's assume that there was this another car which is red in color, right? Another car which was red in color. At point A, say that its initial velocity was 0 meters per second, And finally, when it reached at point B, its velocity was, say, 20 meters per second. 0 meters per second, 20 meters per second. So what is the acceleration of the red car? How much is the acceleration of the red car? Simple. Let's start with the formula first. V minus u over t. What is the final value of the velocity? 20 minus 0. 0 is the initial velocity, right, over t. Time taken was, again, time we are saying the time taken was the same, 5 seconds. The time value we are saying, let's assume that the time value has not changed, 5. So 20 over 5, which is 4 meters per second square. So which car has accelerated faster? The red car has accelerated faster. Why? Because it reached from 0 to 20 faster, right? The red car reached from 0 to 20 in 5 seconds, and the yellow car reached from just 0 to 10 in 5 seconds. There was a more increase in the speed for the red car. There was a more increase in the speed for the red car in the same amount of time as was the increase in the speed seen for the yellow car, which was just 0 to 10. The red car accelerated much more faster. Now, acceleration is a day-to-day term that we use in everyday life, right? For example, if we have to compare the performances of the sports car, we compare how fast they accelerate to reach their top speed. So there are certain sports cars which are quite fast. They reach their top speed in a very small amount of time. Within a few seconds, they reach a very high speed, right? So therefore, understanding acceleration is very, very important. And why is it important? So that when people around us talk about acceleration, we should be able to understand what they mean, right? The inner meaning, the practical meaning of acceleration should make sense to us. Okay, so we'll understand one more practical application of the formula for acceleration here in this case. So please always do remember, u is the initial velocity and v is the final velocity. So we are going to consider here two cases, case 1 and case 2. So in case 1, what are we talking about? So let's focus on case 1. Say that there is a car, right? Let's focus on this picture here. There is a car, okay? It started moving, right? Say that it was already moving. When it was at point A, its velocity, say that its velocity when it was at point A was 5 meters per second. And when it reached at point B, its velocity became, say, 20 meters per second. And the time taken for it to reach from A to B, say that it was 5 seconds. Can you calculate the acceleration? You can pause the video for a bit, calculate the value of the acceleration, and you can play the video again. So what is the value of the acceleration here? Be confident with the formula. There is just one formula for the acceleration that we know of so far. It is v minus u over t. So what is the value of v here? What is the value of v? V is the final velocity. Final is a thing which happens at a later point of time. At a later point of time, the car was at B. So what was the velocity at B? 20 meters per second. V is 20 meters per second. And what is the value of u? U is a value of the velocity which was at the earlier point of time. So initially, earlier the car was at A, so 5 meters per second. When you apply the formula, what do you get? 20 minus 5, and the time taken for this change to take place was 5 seconds. So this whole thing becomes 15 over 5, which is 3 meters per second square. Alright, let us now come to case 2. I'm giving you two values of the velocity. Say that initially the car was at point A and it was moving at a speed of say 20 meters per second, and at later stage it came to point B and its speed was 5 meters per second. Calculate the value of the acceleration. Say that the time taken for the car to move from point A to B is again 5 seconds. Use the formula for the acceleration, calculate the value of acceleration. You can pause the video and play the video again. Okay, so let us apply the formula for the acceleration. Be confident with the formula for the acceleration. There is no other variant of the formula. It is always V minus U over T. And you should be confident in identifying what is the value of V, what is the value of U. So what is the value of V? V is final velocity always. Final means later point of time. Do not get confused. This is where the students get confused. V always means final. U, V, X, Y, Z. That's why the letters appear in the alphabets. U, V, W, X, Y, Z, right? V comes later. V means later point of time. So later point of time, car was at B. Speed was 5 meters per second. Initial velocity, the car was at point A. Initial velocity, earlier point of time, 20 meters per second. Input the values in the formula, 5 minus 20 over 5. How many of you all did 20 minus 5 in the numerator? How many of you all did 20 minus 5 in the numerator? Now this is a mistake which many students make. So you all rush up the things. Many students, they rush up with the things. They interchange the value. They just assume by default that you have to subtract the bigger value of the velocity. You have to subtract the smaller value of the velocity from the bigger value. You have to subtract 20. You have to do a subtraction like this, 20 minus 5. No, please trust the formula. Maths and physics is a subject of formulas. Trust the formulas, believe in the formulas, apply the formula correctly. You'll always get the correct answer. If the formula says that V has to come first, you'll write 5 first. You'll not put 20 first, even if V has a smaller value. Right? 5 minus U, 20 is a bigger number. It comes later. You need not worry in maths. You all have understood. You all already know how to subtract a bigger number from a smaller number, right? You all have done integers, negative numbers, positive number. So why do you get scared of negative numbers? If the answer is coming negative, it's fine. Let it be negative. Negative is also a number and you should be comfortable using negative numbers. That's why negative numbers are taught in maths, so that you understand that these kind of numbers also exist and there is a meaning attached to a negative value as well, right? So let us understand. So one thing that we have understood is that do not interchange the value of U and V when you're inputting the values in the formula just because that you feel like that you have to subtract the smaller number from the bigger number. No. Trust the formula, input the values at the correct place. The answer would be negative 15 over 5. So minus 3 meters per second square. Compare the answers. So the answers are 3 meters per second square in case 1. In case 2, it is minus 3 meters per second square. Did you notice one thing? In case 1, the final velocity was greater than the initial velocity. Final velocity 20 was greater than the initial velocity, which was 5. In the second case, the final velocity, which was 5, was lesser than the initial velocity. These two scenarios are perfectly possible in a day-to-day scenario. Case 1 talks about a scenario when you're speeding up. When you're speeding up from point A to point B. You're moving from point A to B and you're pressing on the accelerator, you're gaining speed. It happens in a day-to-day life, nothing astonishing. Similarly, case 2 also happens in a day-to-day life. You are applying the brakes, say at A, you are at a higher speed, and you come to point B, your speed is reduced. Nothing astonishing. In a day-to-day lives, we see things around us which are speeding up, which are speeding down. So why get confused when you're applying the formula? Always do remember in the formula, V is the final velocity, U is the initial velocity. Do not interchange the position just because you want to make things convenient for you by getting a positive answer. No. Let us understand what this negative term means. The negative term here means, the negative sign here means that you are speeding down. You are speeding down. Negative sign means you are speeding down. That means you are decelerating. That's why negative sign, if you just disappear from your answers, you'll never get to know what is happening. Keep the signs intact. Try to arrive at the correct sign because it will give you a meaning. It will give you a reason. So wherever you see that there is a negative sign coming in your answer, you should understand it is a deceleration. You are speeding down. If the answer is positive, as in case 1, you should understand the thing is speeding up. The car is speeding up. The object is speeding up. It is a acceleration. Right? So if you understand, if you look at scenario 2, one more point I would like to make here. So how much is the acceleration here? How much is the acceleration in case 2? How much is the acceleration? The acceleration here is minus 3 meters per second square. Or you can also say that the deceleration it is a special case of acceleration which we call deceleration. So how much is the deceleration? 3 meters per second square. If you really want to get rid of this negative sign, you have to call your answer a deceleration. Either you say that your acceleration is minus 3 meters per second square, or you say that deceleration is 3 meters per second square. When your acceleration comes as a negative number, you call it a deceleration and you can ignore to call out or read the negative value in the answer or mention the negative value in the answer. Either you say acceleration is minus 3 meters per second square, or you say that the deceleration is 3 meters per second square. So these are the two ways in which you can mention your answer. And please trust the formula, which is very, very important to trust the formula. It is V minus U over T, and never make it U minus V over T just because you want to get a positive answer. Do not be scared of negative numbers. You should be comfortable working with the negative numbers because you all have been practicing this for a long time in your school life now, right? If you're getting a negative answer, it automatically means you are talking about deceleration rate, right? If you have any further questions on this topic, please type in the chat box and try and answer each and every one of them. So here we finish this chapter. We'll be taking up some past paper exam style kind of questions on acceleration after we finish the next chapter, right? So the next chapter is on speed time.